皆様、お集まりいただきありがとうございます。私は OpenAI のグローバル統括責任者、並びに OAI Japan の CTO のコリンです。どうぞよろしくお願いいたします。Today, I'd like to introduce you all to Daybreak, OpenAI's cybersecurity initiative to secure the systems that power our world. Daybreak is not a single product, but an initiative that aims to help our customers stay secure end-to-end. It connects advanced cyber capabilities with the tools that many of your teams use today and the workflows that they rely on every day. On the left are our OpenAI cyber models, which power all the capabilities within Daybreak. In the middle are the product surfaces which you use to deploy these. Codex, our Codex security plugin, and our APIs. And on the right are the security use cases that many of you will use these for in your own businesses. These can be AI-assisted security research, generating a backlog of vulnerabilities and validating them, or maybe even integrating vulnerability scanning into your CI/CD workflows, so that every pull request that your developers write is scanned for vulnerabilities. Importantly, in the enterprise, these security workflows require careful human and model collaboration, and they need to integrate with your existing governance frameworks. So what does that actually look like in practice? This slide illustrates the operating pattern that sits behind that idea. Security is not just about finding vulnerabilities. We can find thousands of vulnerabilities, but that might overwhelm your security team. A key part is then validating and prioritizing which are the ones that we need to deal with today, and which are the ones that can sit safely in the backlog to be dealt with when we need to. Once we've validated them, those are just static code scans that those come from. We actually want agents to imitate our users and go and log into these applications and test them so that we know that these really need to be remediated. Then we actually write the patches, but we also don't want the patches to create more problems, create regression issues, which cause our production systems to go down. And that's where we have to build some kind of proving framework, so that we're going to test these live and allow our agents to validate the changes before they go into production. Ultimately, that is the end-to-end workflow that Daybreak is all about. The demo that you're about to see is aimed to bring that workflow to life. You can see here the user interface for Kyoto Bank's mortgage lending application. Here I can see a customer, Mr. Avery Tanaka, and their details. Clicking through these various screens, I can see the documents they've uploaded to evidence their lending application. I can see a summary screen which gives me some more details. But most critically, I can also log into an admin page, which gives me access to all of my customers and all of their sensitive data. This is an example of one of the places that Daybreak is designed to protect, so that malicious actors can't break in and get access to sensitive customer data. We've built an example application showing how a kind of security scanning framework could be built with Daybreak. I'll kick this off to start with a deep security scan. At the bottom, you can see a series of Codex agents who've all been given skills that help them search for different classes of vulnerability, which might be authentication, APIs, whatever it might be. We have learned from hundreds of these implementations and given a base set of skills so that these agents can operate. So that was the first step of our process. We've now found a bunch of vulnerabilities. But finding is just the first step of the process. We might find tens of thousands. How do we know that these are real vulnerabilities? So one of the things we've done with these skills is helped our agents to prioritize. So in this case, there's been 6 issues, and you can see a criticality assigned to each of those. At the top, I can see one of the critical issues in our authentication flow. If I click open, there's a problem with SQL injection, where somebody could inject some simple SQL into that admin page I showed you earlier, and they will get access to our customer data. The model has told me that this is here from going through the code base. And you can see here the steps that I would need to perform to reproduce that issue, as well as a suggested patch. But remember, the model might think that there's an issue from the code base, but we really want it to prove it. So what I'm going to do is click here. And what I'm going to ask the model to do is reproduce that issue for me so that I can see it acted out in real time. This uses our computer use functionality. where the model will imitate a human user and log into the interface and then attempt to perform this SQL injection. And what I'm expecting to find, unfortunately, is that they were actually able to get access to the customer data by injecting SQL into the admin page. So we found the vulnerability. We've confirmed that it is real. We're now ready to implement a change. So if I go back here, I can drag it into the to-do tray, and I could leave it at this stage for my human engineers. This is where your comfort with this Daybreak framework is critical. You need to build up your own governance framework. You may wish all patches to be applied by human engineers, but in this case, we're going to use a codex agent to carry out that stage for us as well. I'm going to go back to the patch that I thought this agent thought that should apply. And I'm going to actually chime in here as an expert human engineer, and I'm going to give it a bit of advice where I wanted to apply this patch differently. So I'll save that and submit. And it made a minor change to this patch. So again, this is fitting within my existing governance framework. I'm able to give feedback to the model to help it do what I want it to do, but it is still moving much, much faster than I would as an individual human engineer. So now that I've told it exactly how I want it to apply the patch, I'm going to tell it to move forward and apply it. If I scroll down here, this bit is also auditable. So I can see the agent is logging everything that it's doing, and it's telling me what steps it's carrying out. And there's a key piece here. The model is carrying out the patch, but it's also leaning on all the controls that my human engineers need to adhere to write production code. You can see here that my unit tests have passed, and my regression checks have also passed. So I'm reasonably confident that the patch has been deployed successfully, but it's also not caused regression impact into our production system. And this is a key aspect. We need to make sure that the model is accurately testing its changes and replicating our production environment so that we can have confidence in what they're doing. This is a key part of Daybreak, of baking in an environment for the model to replicate your production environment and make sure that these are durable and effective patches that it is applying. So the last step here is to ask my agent to now test its work. So we now have a copy of the production system set up, and I'm going to again ask it to try and inject SQL and break into the admin interface. And what I'm expecting to see here is that we'll apply this, and it is successfully blocked. So this is a simple example of how you can implement a single change. But imagine thousands of vulnerabilities across your enterprise. That is where this sort of framework really starts to generate a ton of value. When you tune those skills of how it prioritizes, you can also tune the tests that it uses. So maybe it could have, if all of these tests passed automatically, we could have safely passed that through to production without needing a human engineer in the loop. But that is up to you to build the framework that you are comfortable with, and this provides all of the tools to do that. So hopefully this is the vision of how we'll automate security at scale with SoftBank, and hopefully with all of you in the room. Today, hopefully you've gotten a taste of our shared vision of AI security with SoftBank. We don't simply want to use AI to do traditional work faster, but we want to reimagine how that security process gets work done. And in the past few months, SoftBank has been uniquely positioned to help us because they have been working with us to accelerate this vision into reality by testing us with them on their own systems as our customer zero. Together, we have the opportunity to establish a new standard for trusted AI in cybersecurity. We invite all of you to help us build it together. I'd like to thank all of you for having me, and I'll pass you back to the SoftBank team.
Hey, Max, thank you so much for coming.
Thank you for having me, Masayoshi.
Yes. I know you are responsible for all the new models that's OpenAI creating. Is it an exciting job?
Yeah, it's exciting, and I think the pace has really picked up. I think we are living in a future where the models are starting to create themselves, and so we're seeing, faster and faster progress on AI.
So you actually discuss with the model, you create the model, and the model is also making the model
Yes.
by themselves, right?
Yes, absolutely.
Isn't it sometimes scary that the model create the next model by themselves, but you may sometimes not understand every detail why it's coming like that.
Yeah, I totally agree. So we put a lot of work into safety and alignment of the models. And for instance, when we have the models reason, one thing we care about is we can interpret and read what the model is thinking.
Yes.
So there's a lot of safeguards that we build in just to make sure that the model is aligned with what you and I want.
Yeah, so you see how the model is thinking
Yes.
and creating the next step, blah, blah.
Exactly, yeah.
But
And
isn't it so fast?
it's so fast, but the interesting thing is it's like how you and I think. The model will get excited. Sometimes it's
Model get excited.
yeah. Let's say it's trying to find a vulnerability for you.
Yes.
Sometimes in the thinking you can find the point where it finds it, and it's like, wow, I found it.
So
And
model say, wow, I found it.
yeah, it's very human-like.
Yes.
Yeah.
So it's almost like model is having its own emotion or excitement, whatever, sort of, right?
Sort of. Yeah,
Sort of.
its own way of.
Its own way of, yes. Well, so the model is evolving so quickly. The number of chips being deployed at the data center increasing dramatically. Of course, it requires a lot of capital and power, but the number of chips per model utilized is increased. Chip itself, the performance increases dramatically. Model itself gets smarter. So, what happens in 5 years from now? What's your view? How quickly, how drastically model gets smarter?
So I think one thing for everyone to note is that over the last 8 years, model intelligence has been predictably scaling up and up. And so it's not a new thing that the models are suddenly smart. Over the last 8 years, they've been incrementally on an exponential getting smarter. And that trend is probably going to continue. When we look at the research, all the ways to put more compute in the models, by pre-training them, making them their brains bigger, by teaching them how to reason, how to chain together all the knowledge, all of those things are continuing. And so we expect that trend line to continue.
But it's accelerated.
Yeah, no,
It's not linear.
Yeah, no,
It's
it's
not linear.
on an exponential. It's on an exponential. And I think when you talk about compute, right, I have a team, they're a bunch of hungry researchers. They all want compute because that's how they train and advance the capabilities of the models. And I think if tomorrow you gave us 3 times the amount of compute, we'd be able to completely saturate that. If you give me 10 times the amount of compute, very quickly we could find the right experiments to run. So, compute is this bottleneck, and we're seeing that, data center build out also follow this exponential as well.
So if the size of the compute, the number of chip increased by, let's say, 100x from now, okay? Let's say in 5 years, I pick just a number. In 5 years, let's say 100x from today, the number of chip increase, each chip performance increased dramatically, and the model also makes smarter. Right now, let's say, this morning you were mentioning the model's IQ level is maybe around 180 or something, 100.
It's very smart. Yeah. So right now it can prove new mathematical theorems that have been unsolved for 100 years. And it's just a year ago, right? The models were kind of solving college level math problems. So if you keep extrapolating, the models are going to keep getting smarter. And one way we like to think about it is think about the amount of time it takes you to do a task. The models, their reliability, every year, you expand that by another factor. So last year, if the models could do something that takes humans 1 hour to do, now it takes 4 hours. And roughly the trend has been 4 times year over year. So, next year we're getting to, models that can operate on tasks that take humans a day, and then we're going to go a week, and then further from there.
So if the model's IQ level is 180. I haven't seen anybody who's 180 myself, but if it goes that much, smarter, 5 years from now, drastically smarter, and then it start to do something bad on cyber security, as we are talking today. Isn't it very scary?
Well, I think cyber is a very interesting capability because we call it a dual use capability, which means that even though the models can get better and better at finding vulnerabilities, we can use that for defense
Yes,
as well.
of course.
Yeah, and I think the important thing is we can go and try the models and try to find the vulnerabilities before external actors can go and try to find those vulnerabilities. So I think what matters is earlier access to the frontier models, and also a lot of compute, right? If you have more compute as a defender, you're going to have a better way of being able to patch everything.
It's like a bad criminal has a knife, and then police has a gun.
Yes, absolutely, absolutely.
Right? The bad criminal with a knife, with a police who says has a gun and says surrender, hold up, right? The criminal will surrender because he has only the knife. If it's opposite, if the criminal has a machine gun and we have only knife, we are in trouble.
Absolutely.
Right? So that's why we, as a defender, we have to have the best, most powerful weapon so that we can defend against the bad guy. That's a theory, right?
Exactly, yeah. And I think when we thought about cyber, recently I just talked about how the models were solving these 100-year-old unsolved math problems. And if it can do that, if you point to cyber, of course it's going to be able to find cyber vulnerabilities. And I think our models have been very successful at that. We believe we have the best-in-class model. And just like you've heard, it's finding tens of thousands of new vulnerabilities. And beyond that, we're also finding new vulnerabilities in things like Chrome and Firefox and all of these different settings. So they're real significant vulnerabilities.
Yeah. So it's going to cost to do the protection. How the company should think about it? Is it the cost necessary as a new life, or is it the investment? If this new situation did not come, the cost did not exist. So what do you think about that?
Yeah, I think cyber vulnerabilities have always been around, right? But I think what has changed in the world is now there's the ability for people to find them much faster, right? And much more cost effectively. And you can think about this. If the models are going to keep getting that much smarter every year, imagine you have a 180 IQ model that's trying to find vulnerabilities, but next year, there's a 200 IQ model that's trying to find the vulnerabilities. So they're going to be able to find deeper vulnerabilities. And I think, it's really, a long game, right? You have to make sure you patch according to the frontier vulnerabilities, and then in the future, you have to apply more compute so that you can harden against the deeper defenses.
Yeah. So it's a necessary cost to keep the company running.
Mm-hmm.
Okay, so it takes a lot of expertise, and if you try to patch it, like in a bank, if you try to patch it, you find a vulnerability, try to do the patch, and then if you by patching, if the system stop, right? Then it's a real issue. In Japan, if the bank system stop, the chairman get fired. so it's a serious issue. But it's not just about a chairman; it's a society have a real issue. And so even if we find a code for patching, do the actual patching is scary. So we have to do the test before patch. And even we do the test, make a copy and do the test, and then decide to do the operation. Once operation done, and then actually issue happens, then we have to grow back, right? To undo it and grow back and find additional solutions to be more careful. So that kind of thing cannot be fully automated. You have to, like a doctor, you know, you get a lot of advice and solution, but the doctor have to decide at the end, do I do the operation surgery or not, right? So that kind of decision, still the human responsible have to judge and create a solution back, right?
Yeah, so I think the important thing to remember is finding the vulnerability does not solve the problem, right? I think, like you said, you're going to find thousands of vulnerabilities. Some of them are going to be severe. Some of them, really, you can kind of live and not really worry about. And so I think there's a broader exercise we need to do to really triage these, make it very clear which ones are the important ones to fix. And of course, we are putting a lot of work in our research program right now to also patch the vulnerabilities, right? It's not enough to find the vulnerabilities. You also want to be able to figure out how to patch it. And oftentimes, these are hard problems, right? They touch other parts of your code base. And we see a lot of similarities to, let's say, code migration, right? You just need to understand deeply the whole code base and be able to make something that's resilient and that doesn't cause another problem.
So, patching is important, finding vulnerability important. You do it for your own company. But, I've been the CEO of our telecom mobile company for many years, and I have really experienced that our network, mobile network, telecom, get shut down when blackout of electricity happen in that region because of the earthquake. If the earthquake happens, the first power company get blackout. If the power company get blackout, our telecom stop, right? Even though our telecom itself is okay, because of the blackout, the whole mobile network get stopped. So infrastructure related each other, right? Critical infrastructure all related each other, and so it's not just our company that we have to protect, the whole society have to protect, right?
That's why we're excited to partner with you guys. I think there's a lot of expertise that you can learn from applying patching to one particular environment, and patches transfer, right? Like we know critical infrastructure in Japan. It could be fairly similar from one environment to another. So part of the reason we love to work together is just take those lessons and generalize them across different settings.
Yeah. So even within SoftBank, we are now experiencing on the patching. Do we actually do it? Oh, it's very scary.
Yeah. Because you have limited resources.
Yes.
You have to figure out what is the most effective use of human time.
Okay, so now, how does this cyber attack with AI became so powerful? Are you using bunch of agents, do so many times, so many attacks?
Yeah. So I think really the trend with agents has been that the amount of time and the amount of compute power they use to think has also been growing exponentially. And I remember we were starting the agent program at OpenAI and the thinking and reasoning program back in 2020. And since then, the amount of compute that the models are using productively just keeps going up exponentially. And so you can think about it as the model is just, it's like a human, right? Like an expert human thinking for that much longer on how to break a particular system. And like I said, the task horizon is increasing by a factor of, let's say, 4 every single year. So now you can imagine it's an expert human spending a day or a week trying to break into a system. And that's where the power is coming from. 3 years ago, if you take that back, 3 multiples, maybe it's a person thinking for a minute, and that's not enough to really break into the system.
So it's not, my understanding, it's not just one task, one brain. You have a massive parallel number of agents. The agents, massive parallel agents, they're attacking from many different paths, right? Simultaneous.
Exactly. Yeah. So agents increasingly are working together and can parallelize their compute such that and can coordinate to solve one particular objective. And we expect that to continue.
So it's not one wolf, it's a pack of wolves working together, discussing together how to attack and massively parallelly.
I think that's a good analogy, but that's also what you want defending your systems, because if you imagine the adversary, the attackers, that's the way it's going to be too,
Yes.
right? You're not going to have one organization trying to break in. It's a heterogeneous ecosystem. So
Yeah, so as the defender, you have to have a
yes,
massive number of agents come up with a solution.
hardened system. Yeah.
And faster patching. The human coder cannot do the patching quick enough.
Yeah.
And you have to use this AI agents to create a patching in such a high speed.
Yeah, and we're investing a lot of research energy just to make sure even when we're generating code for you, that it's robust to all of these attacks in the future. So we're kind of completing the loop there as well.
So what I'm really afraid of is that, these new trends get copied by other countries very quickly, as Miyakawa was talking about, very quickly, and they are open source. So it's not just one company or one country. It's open source, so bad guy can use the open source much easier, much more access, and many more different. So it's like a new variation of virus, right? They have many bad guys now has a many different tweak of different attack that they develop by themselves, right? So we have to have a much more stronger protection.
Yeah, I think it's very important for frontier labs to stay at the frontier, and I view that as my job, right? I succeed when we really push the frontier of capabilities and we push it with velocity. And I think when you talk to most research scientists today, even at other labs, there's some consensus, we're maybe 9 months ahead of the open source wave. And I think that buys everyone a lot of time, right? It's sufficient. I think, if we go and we, really harden against frontier models today, it buys us another year of, peace of mind.
So we have to keep on running.
Yes, yeah, absolutely. We have to keep on running. That is my job. Keep on running with the model.
Keep on running, more compute.
Of course, yeah.
And it's our job to protect Japan. Your job, to protect whole world together, right?
Yeah. And we love to partner on this because I do think Japan is ahead of the curve. So one thing I just learned on this trip is Japan, right after the US, is the largest active user of codecs. And yeah, I think that really means that people are embracing agents here, people understand how to use AI. And I think we should use this as a partnership, especially as our nations are close, to harden against cyber capabilities.
And SoftBank is like a customer zero. We did this vulnerability test, and then second time, third time, fourth time, we find new vulnerabilities, and that is something we did not know until we actually tried it.
Yeah. No, I think, we were talking about it this morning, and I think the analogy is correct. So when you think about why that's the case, I kind of think about it as a vulnerability is like an apple in an apple tree or something. And you say, you tell an agent, you say, one day, pick as many apples as possible. So I think if the agent is smart, it's going to go pick all the low-hanging fruit first. So you find a lot of vulnerabilities. But then you say, okay, day 2, I give you the same amount of time, same amount of compute, and go find more vulnerabilities. Now it has to work harder to find each vulnerability, and so it finds more.
Because the first apples around
exactly,
surface is all gone.
Yeah. So I mean, that is the way to think about compute, right? And the way that these models are going and exploring and finding properties.
Okay, so we have restless days. We have to keep on fighting to protect from the bad guys. Oh. Thank you so much.
Thank you all.
ありがとうございました。